Now next topic is derivative of function. Suppose f is a real valued function. F is a real valued function and A is any number belonging to domain of f. Then the derivative of this function f at A is defined as derivative of function at A is defined as limit h tends to 0 f of a plus h minus f of a upon h. Limit of this function as h tends to 0 is said to be derivative of f at a. It is denoted as f dash of a. So here f dash of a is limit h tends to 0. Now this value is f dash of a, f of a plus h minus f of a upon h. So this is the definition of derivative of function at a. So f is any function, then this is a new function whose limit as h tends to 0 is the derivative of f at a. Say here in this function h is variable, h tends to 0, whatever symbol we keep on left of this arrow, it is a variable, this is constant. Now we can put another form of this definition. Another form of definition. So in this form, if we take a plus h equal to x, now changing variable, taking a plus h equal to x, therefore h is x minus a. Here I will put x minus a. And as h tends to 0, as h tends to 0, x tends to a. Here a is constant. So this number is constant. H is variable, h is not constant. So changing its form, f dash of a, f dash of a is equal to limit, now h tends to 0 will be replaced by x tends to a, and a plus h is replaced by x, f of x minus, this is constant, upon h is x minus a. So this is second form of same definition. Derivative of f at a. A is any number belonging to domain of f. If you put here b, keep here b, b, b. If you keep here c, put here c, c, c. Here x is a variable. Instead of x, you can use any variable. If instead of x, you want to put t, then put here t. Then here t tends to a. If you want to put y, put here y minus a. So y tends to a. Let us keep here t. Suppose I use t instead of x, I am using a t. So this will be t minus a. This will be t tends to a. So here a plus h is t. This will be t minus a. This is t. So say this is a variable. Here you can use any symbol. You can use your x, x, x. Put here y, y, y. Any symbol can be used as variable. And whatever you put here number, same must be here. In this form also. If you put here 5, so put here 5, 5. If you put here 6, then put here 6, 6. And h is variable. This must be fixed. In this form of definition, this 0 must be fixed. H tends to 0 is fixed. Whatever you keep here number, a is any number, but this is fixed. No change in 0. And in this form of definition, whatever you keep here, that number should be here. If you put here 7, put here 7. If you keep here 8, put here 8, 8, 8. So using any variable, this definition can be written. Now here, if I replace this number a by x, if x is any element belonging to domain of function, then replacing a by x, f dash of x equal to, now a I am replacing by x, f dash of x equal to limit h tends to 0 f of x plus h minus fx upon h. I replaced a by x, 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 x. Or second form of definition, here replacing a by x, limit t tends to x, a is replaced by x, 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 say x, 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 x. T is variable, keep as it is, f of t minus fx upon t minus x. So this is said to be derivative of f at x, derivative of, then the derivative of f at x is denoted and defined by this definition. If y is equal to fx, if y is fx, then derivative of f means f dash x is also denoted as dy by dx. Then f dash x is also denoted as dy by dx. Y is fx, then f dash x is denoted as dy by dx, or this is also denoted as d by dx of f. Y is fx, so dfx, derivative of fx with respect to x. So this is derivative of fx with respect to x, derivative of fx with respect to x, or derivative of y with respect to x, that is dy by dx. So this is the definition of derivative of function at any number x. Now, working rules. See, first rule is derivative of fx plus gx. Derivative of fx plus gx is derivative of fx plus derivative of gx. Sum of derivative with respect to x is equal to, derivative of sum of two functions is equal to sum of their individual derivatives, or if you put here difference, then put here difference. Derivative of difference is equal to difference of their individual derivatives. Second property, for any constant k, derivative of k into fx, if k is any constant which is in multiplication with fx, then we are taking this k outside, k into d by dx of fx. Third rule is d by dx of fx into gx. D by dx of fx into gx, the rule is keep fx as it is, multiply derivative of gx, then plus, second time put gx as it is, multiply derivative of fx. D by dx of fx into gx is fx into d by dx of gx plus gx into d by dx of fx. Derivative of quotient of two functions. Derivative of quotient of two functions, the rule is here denominator is gx, so put here gx square, then put gx as it is. Here denominator is gx, put gx square, then whatever you write here, same number right here, gx into derivative of fx, then minus fx as it is, derivative of gx. So that is rule for quotient of two functions. See, in short, these rules can be written as, if u is function of x and v is function of g, then see, first rule, repeating, d by dx of u plus minus v is d by dx of u plus minus d by dx of v. Second rule is d by dx of k into u is k times d by dx of u. Third rule is d by dx of u into v is equal to u as it is d by dx of v plus v as it is d by dx of u. And this fourth rule will be d by dx of u upon v, that is put here v square, as v is in denominator, v square, v as it is derivative of u du by dx, then minus u as it is dv by dx. So these are working rules of derivative of functions, and here d by dx of fx, that means f dash x, that is dy by dx if y is equal to fx, and this is the definition of f dash x. Now question based on definition, find derivative of function at given number. Say derivative of f at x equal to a is f dash of a limit h tends to 0 f of a plus h minus f of a upon h. We are using this definition. Say in this question, here this is fx. Fx is x square minus 2. We want to check derivative at x equal to 10. So a is 10. So f dash of 10 at x equal to 10, that is f dash of 10. Derivative of f at x equal to 10 is, by this formula, limit h tends to 0 f of, now say here number a is 10, so put here 10, 10. So f of 10 plus h minus f of 10 upon h. This is a. F dash of a is f of a plus h minus f of a upon h. Here h is variable. Now f of 10 plus h, f of 10 plus h, so putting here 10 plus h, so this will be 10 plus h whole square minus 2. So this is f of 10 plus h. F of 10 plus h is 10 plus h whole square minus 2 minus f of 10. F of 10 is 10 square minus 2 upon h. So this is equal to, now it is a limit of, it is a question of limit. Now simplifying this, 10 square is 100 plus 20h plus h square, 10 square is 100 plus 20h plus h square minus 2. Then this is 100 minus 2. 100 minus 2 is 98. So this is minus 98 upon h. So say here 100 and this is minus 100. So this is cancelled. So limit h tends to 0. Now in these remaining numbers h is common. So 20 plus h upon h. This h is cancelled. So limit h tends to 0, 20 plus h. Now this is the simplest form, free from denominator. Now put h equal to 0. So value is 20. So derivative of f at 10 is 20. Now here fx is cos x. We want a derivative of cos x at x equal to pi by 2. So we want a derivative of pi by 2, derivative at pi by 2. Put here pi by 2. So f dash of pi by 2 is limit h tends to 0, f of pi by 2 plus h minus f of pi by 2 upon h. I replaced a by pi by 2, pi by 2, pi by 2. So that is limit h tends to 0. Now f of pi by 2 plus h. So putting here pi by 2 plus h. So I am putting here pi by 2 plus h. So it is cos of pi by 2 plus h minus f of pi by 2. So f of pi by 2 is cos of pi by 2 upon h. That is limit h tends to 0. Now see, cos pi by 2 is 0. This is 0. Here we expand this, cos alpha cos beta minus sin alpha sin beta, cos alpha cos beta minus sin alpha sin beta. Cos pi by 2 is 0 upon h. Now again this is 0. So 0 into cos h minus sin pi by 2 is 1, 1 into sin h upon h. 0 into anything is 0. So this is now minus limit h tends to 0. What is left? Minus sin h upon h. And limit of this function is 1 as h tends to 0. So it is minus 1. So derivative of function at pi by 2 is minus 1. So this is the application of this definition. Now find the derivative of this function from first principle. See, first principle means definition. First principle, that is definition. Derivative of f at any number x is f dash x is limit of f of x plus h minus fx upon h, h tends to 0. This is first definition. This is first principle. Means nothing but definition. So using this first principle, we are finding derivatives. Say here, function is fx equal to x cube minus 27. We want f dash x. F dash x is, first principle is limit. So from this first principle, f dash x is limit h tends to 0, f of x plus h minus fx upon h. So from first principle, now we are finding f dash x. So limit h tends to 0, f of x plus h, I am putting here x plus h, x plus h. So f of x plus h is x plus h whole cube minus 27. F of x plus h is x plus h whole cube minus 27. Then minus fx. Fx is x cube minus 27 upon h. Then this is limit h tends to 0. Now see, here this minus 27 and this plus 27 will be cancelled. So this is f of x plus h whole cube, expanding this, x cube plus h cube plus 3x square h plus 3xh square, expansion of this x plus h whole cube, this is minus x cube because this number will be cancelled upon h. And now see, this x cube is also cancelled. So this is equal to limit h tends to 0. Now here in these numbers h is common, so h square plus 3x square plus 3xh upon h. Again this h is cancelled. So limit h tends to 0, h square plus 3x square plus 3xh, and now putting h equal to 0, this is 0 plus 3x square plus 0. See, h is variable, not x. In this whole discussion, x is fixed. This is variable. X is fixed. It can be any number from domain, but it is fixed. So f dash x is 3x square. So that is derivative of this function. This is derivative with respect to x. Now here fx is x plus 1 upon x minus 1. From first principle is f dash of x is limit h tends to 0, f of x plus h minus fx upon h. Now putting values, limit h tends to 0, f of x plus h, so putting here x plus h, x plus h, x plus h, so f of x plus h is x plus h plus 1 upon x plus h minus 1. So this is f of x plus h minus as it is fx. Fx is x plus 1 upon x minus 1 upon h. Now simplifying this, limit h tends to 0, say this will be, now we are taking LCM in the numerator, LCM comes in the denominator. So here LCM of this numerator terms is x plus h minus 1, x minus 1, this h we are keeping as it is. LCM of these numbers I am writing in denominator. Now this will be multiplied with this number, so x minus 1 into x plus h plus 1 minus this will be multiplied with x plus 1, so x plus 1 into x plus h minus 1. Now simplifying this, limit h tends to 0, x into x is x square plus hx plus x minus h minus 1. Expanding here, minus x square minus hx plus x, then 1 into x minus h plus 1 upon x plus h minus 1, x minus 1 into h. So x square will be cancelled, hx will be cancelled, x cancelled, again x cancelled, minus 1 plus 1 is cancelled. What is left in numerator? Minus h is minus 2h upon x plus h minus 1, x minus 1 into h. This h again cancel. So what is left? Limit h tends to 0 minus 2 upon x plus h minus 1 x minus 1. Now we replace h by 0. Only this is the place where h exists. So this h, here I am putting h equal to 0. So this is equal to minus 2 upon x plus 0 minus 1 into x minus 1. So it is equal to minus 2 upon x minus 1 whole square. So that is required derivative. This is the derivative of function with respect to x. Find the derivative of cos x from first principle. Say here fx is cos x. Now first principle is f dash x equal to limit h tends to 0 f of x plus h minus fx upon h. So f dash x is equal to limit h tends to 0 f of x plus h. Put here x plus h. So this will be cos of x plus h minus fx is cos x upon h. So limit h tends to 0. Now cos c minus cos d. Cos c minus cos d using a formula. Cos c minus cos d is minus 2 sin c plus d by 2 sin c minus d by 2. Cos c minus cos d minus 2 ss upon h. So that is limit h tends to 0 minus 2 sin x plus h, x is 2x plus h by 2 into, here x is cancelled. This will be sin h by 2 upon h. Now see, here we can use standard form of limit. This is sin h by 2. So same number should be here, h by 2. So what I do? Divide by 2, multiply by 2. Divide and multiply by 2. So this 2 is cancelled. Now distribution of limit minus as it is, limit h tends to 0 sin of 2x plus h by 2. So limit of this function after taking minus outside into limit of this function, limit of sin h by 2 upon h by 2, h by 2 upon h by 2, h tends to 0, so h by 2 tends to 0. So minus, now replace h by 0, so sin of 2x plus 0 by 2 into, this is 1, so this is minus sin x. So derivative of cos x is minus sin x. So when finding derivatives for trigonometric functions, we have to use here trigonometric results. Cos c minus cos d minus 2 sin c plus d by 2 sin c minus d by 2, or if you want sin c minus sin d, then use 2 cos c plus d by 2 sin c minus d by 2. So trigonometry is required in calculus part. Now in this question, here fx is cos of x minus pi by 8. Similar method from f dash x is here limit h tends to 0 f of x plus h minus fx upon h. This is first principle. Now putting values, f of x plus h, so I am putting here x plus h, x plus h. So f of x plus h is cos of x plus h minus pi by 8 minus fx is cos of x minus pi by 8 upon h. Now once again same application, cos c minus cos d. So limit h tends to 0, cos c minus cos d is minus 2 sine c, this is c, plus d, c plus d by 2 sine c minus d by 2. Cos c minus cos d minus 2 sine c plus d by 2 sine c minus d by 2 upon h. If you are given your sine function, then you will have here sine c minus sine d. So in that case you have to apply 2 cos c plus d by 2 sine c minus d by 2. Now look here, this minus pi by 8 plus pi by 8 is cancelled, x is cancelled. Again there we are getting sine h by 2. So procedure will be similar to like this. So this is equal to limit h tends to 0 minus 2 sine, here x plus x is 2x, x plus x 2x plus h minus pi by 8 minus pi by 8 is minus pi by 4 divided by 2 into sine of h by 2. This is h, this is 2 upon h. Now similar procedure, here divide by 2, multiply by 2. So here we can apply rule of limit for sine function. This 2 is cancelled. So minus take outside, limit h tends to 0, sine of 2x plus h minus pi by 4 divided by 2. We can also put this in simple form or keep as it is, into limit of sine h by 2 upon h by 2, h by 2 tends to 0. So distribution of limit. Now minus sine 2x plus 0 minus pi by 4 by 2 into, this is 1. So derivative is minus, so it is equal to minus sine 2x by 2 is x, x minus pi by 8 into 1, that is same number. So derivative of cos of x minus pi by 8 is minus sine x minus pi by 8.